Inverse function derivatives. There are a couple ways to do these. I'm going to run through both of them. One is just calculating the inverse, and then taking the derivative. The other is actually just using a formula. Okay. So, okay, so part of this requires that you know how to calculate inverse function. This is one method you can use. Hopefully you'll avoid it for the most part, because it does take long. This is one way to do it. Okay, so we need to calculate the derivative of g, where g is the inverse of f. Remember how to find the inverse of f. Switch x and y, that's inverse. Okay, that is the big idea here. You're going to see why that matters with the formula. Okay, so you write it out, switch x and y, and solve for y. Okay. Plus 2 divided by 3, right? Get closer. Does that make it easier to see? There you go. So it's later. So, if there's no function top or bottom, say it's just a number, you don't have to use a quotient rule. You can make it simple like we did on the warm-up. Don't make it messy and nasty. Okay? Simplify if you need to. You make it easy on yourselves. Okay, so, that's the very straightforward version. Inverse derivative. Notice this, what's the derivative of that? 3. This is 1/3. Are they perpendicular? No, they're not, because it's not a difference in a negative. Okay, so they do differ by reciprocal, but not in linear, but not, definitely not. Right. So here is the formula. Show you how to use it. anybody know what one-to-one means?
There's one.
Remember, a function is every x has one y. A one-to-one function also has one y for every x. Keep in mind, if we just pass the horizontal line test. One-to-one. That's x squared, right? Does any y value have two x's? Y value, x, and x. This is not one-to-one. It's a function, because every x has one y, but it's not a one-to-one function because y has two x's. Right, so that's past the horizontal line test. That's what one-to-one is. For this formula to work, that has to be true. So we're going to set the F inverse, we're going to call it G. If E inverse, F inverse, E belongs to the domain of G. Remember, the domain of G is the range of F. We switch x and y, right? Because the domain x value in the inverse is a y value in the original. Right? So you might note that. And if we're going to use that piece of knowledge to solve these problems, switching x's and y's. We cannot have this. Let's see why. So all you have to calculate to find the derivative of an inverse using this formula, you calculate the derivative of that, the original, and plug G of theta. You don't have to do any inverse derivative. This formula gives you that. So this helps you avoid this entire calculation. I'm going to show you how to make this really easy. It looks really complicated right now, doesn't it? It's not that bad. Calculate G prime of 1, where Ux is the inverse of f of x equals x plus dx. The derivative of inverse. You're not given a whole lot of information. My first thought is, can I calculate the inverse of f? I think you probably could, but here's how much easier it is. You are given G prime at 1, right? So in G, that is an x value, correct? Where is that in f? See, we're switching x's and y's. How can I find that value? 0. Yeah. equation, I now have my x value here and my y value here. And see how I put 1 in for y? I have x. Now if I solve it, what is my x value here? The key of the 0 is 1 plus 0. Anything to the 0 power is he just thought of it. Right. Oh wow, logically this makes sense. The other way to do it is to solve it. And the best way to do it is to take this one. Most of the time you can solve it. X is 0. Does it? So, to the formula, you need G of B, which we just found. B is 1, the result of that is 0. So, let me write that formula down. We also need F prime, right? What's F prime? So, G prime at 1 over F prime at G of 1. Right? What is G of 1? 0. What's F prime at 0? So, yeah. F prime at 6. Understand how I got here? So I put G of 1 is 0. So I need F prime of 0. F prime of x here. So I plug 0 in. 1 plus 1 is 2. Okay. So this is a different way to calculate the derivative of an inverse because we might need it. You can't always calculate the inverse. So again, the key here is to put these like this. So that you can see that you're just, you got an x and a y, or I can solve for my x value here. And then I can transfer it, and then everything should fall out.
So why do we have to do this
That tells me this value. Because I know that all I was given is calculate G prime of 1 and F. So this helps me see that G prime of 1, or G of 1, is the y value for that. When we're switching x to the y's. So if I know that the y value is 1, I can set it equal to the function and solve for x, which gives me this value, which I need. So that's using the formula. There is a more complicated example in your book of that. It's f of x to the 4 plus 10. They restrict the domain so that it's 1 to 1. So if you want to see a more difficult example of something like this, you have to one. Inverse. Yeah. There are inverses of all the 6 trig functions. Okay? Those are in your book. You want me to write it down? If you memorize the 6 trig functions inverses, derivatives, sine inverse, so that's the derivative of that. You're probably going to earn another point or 2 on it. Okay. So, and I can kind of show you the patterns there with those. Remember the patterns I showed you, the sine and cosine, negative sine, how some of those patterns line up. The same kinds of things happen here. They're messy, but number 1 plus. What? They're the same except for sine. So we were thinking, what's the derivative of sine? Cosine is positive. What's the derivative of cosine? Negative. So, see that kind of matches a little bit with the ones you already know? Okay, so that if there's a derivative of cosine or cosine inverse, it's negative. You can also do the rest of them, the others, tangent. What do you think cotangent is? The negative of it. So you really only have like 3 things to remember, and you just negate them for the other case. Okay. Secant, this is where they get out of it. And cosecant. Again, just if you memorize them, you got 3 of them, and then the others are just the negation of it. Most likely, you would have this as a chain rule problem. You see one of these on the 18th day. And ask you the chain rule. You have to know this, and you have to use the chain rule. When you're done, I'll show you one. Pick one. So you want me to show you the just go sign? The derivatives of inverse trig functions. Right, let's calculate Yeah. So notice that it's not just X here. Right? So on the outside function, inside function is the chain rule problem. So we have out and inside. The derivative of the outside, the reverse derivative outside. X squared, 1 minus x squared. And I have to copy the inside of it. The derivative is 1 minus x squared. My x value is this. Okay. Derivative outside, copy inside. What's the derivative on the inside? It's the same pattern as before. You just have a new derivative outside is this, copy the inside, and derivative inside. Okay. Good? I just leave it. There's nothing you can do with that. You might say, how do you make it at 1? 1 going in, you do that. That's enough. Need some more chain rule practice here. You need it. So right now, the schedule I have puts us finishing this chapter when testing on Wednesday, not next Monday, but the Wednesday after. And then we have our test grading early on circle. And that Friday is kind of a nebulous day. So we have an option next week if you want to just take a day and practice. Do something different besides the lesson we can. Otherwise, next week is bam, 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 4 days of lessons. So, if I'm looking at our schedule, so if you want to take a day next week just to kind of get your brains in practice mode and, yeah. Okay, so Wednesday or Thursday, one of the two, I'll pick the better of the two that I think would work for us. We will do that. The nice thing is it'll give you 2 days work, it'll give you 2 days to do it. So on the Google Classroom, I put everything we do back. I already scheduled it out for the test code. Next week we'll have a practice day, hopefully we'll bring a little bit of a break on new stuff. Start your work, start your homework.